My name is Dia Dada, and this is our stat performance final.
Okay, so the item we used was socks, the categorical variable being the color of the sock. We used white socks, which I'm holding is this colored sock, is what Dia's holding. And our quantitative variable was the length of the sock measured in inches with a ruler.
These are two histograms that are showing our quantitative data, which is the length of sock. The distribution on the left is skewed right. There are no gaps or outliers. It has a median of 15.75 where the center is and a spread of 3 based on the IQR. We are using median and IQR because our distributions are skewed. In comparison, the distribution on the right is also skewed to the right, but it is less dramatically skewed. It also has a higher center because its median was 17.25, and it has a much larger spread with an IQR of 7. Here we have segmented bar graphs showing our categorical variable, and the relative frequency for the color of sock was not the same between our two datasets. This is seen in the bar charts where David has a higher frequency of white socks than I did. He had a frequency of 0.55 white socks compared to my own frequency of 0.33 white socks. David had a higher relative frequency of white socks while I had a higher relative frequency of colored socks.
Okay, so for both samples, we found every possible sock we could have in our house, which created a population of just over 300 socks per household. We then performed a simple random sample by putting all the socks into a bin, where we would randomly select 30 socks. And the only major type of bias that could possibly occur is under coverage, because certain colors of socks and certain lengths of socks might be underrepresented, especially if we poorly organize the socks within the bin.
Okay. I used our dataset to construct a binomial model. And we identified success as a colored sock and failure as a white sock, and we found our parameters. And we satisfied all the conditions because each sock is either white or colored, meaning that the only two possibilities we have are success and failure. We also have a fixed number of observations, and n equals 60. Each observation is independent from the other because the color of one sock does not affect the color of the next, and the probability of drawing a white sock remains constant throughout because the sock is being replaced. Here I created a sampling distribution with a sample size of 2 being repeated 30 times. Here are my parameters, and the reason the sample size of 2 is problematic is because it's too small. In order for the central limit theorem to apply, the sample needs to be at least 30.
Okay, so for the categorical variable, I decided to do a two sample z interval for the difference in proportions, with the success being portion of colored socks. Our null hypothesis was that there was no difference in proportions, and our alternative was that there was a difference. We used a significance value of 5%, and our p-hat values for myself was 13 out of 30, and for Dia was 20 out of 30. Our model was the difference of proportions of colored socks is distributed normally with a proportion of 0 and a standard error of 0.125. Our assumptions and conditions were the random selection of stocks in most samples was satisfied. Large sample condition was satisfied because both our successes and failures were greater than or equal to 10. Our groups were selected independently of each other, and while independent selection did not occur within each group, 10% condition was met because our population was greater than 300. Our confidence interval ended up being negative 0.4781 and 0.01141, which does contain 0. Because 0 is contained within the confidence interval, we failed to reject the null hypothesis. There's not enough evidence to suggest there is a difference in mean in the proportion of colored socks that between myself and Dia.
Right.
And then for the quantitative variable, we decided to do a two-tailed, two-sample t-test for difference in means. Once again, our significance value was 5%. Our null hypothesis was there was no difference in mean, and our alternate was that there was a difference in mean. My X bar ended up being 17.55 inches. Dia's ended up being 16.05 inches. My standard deviation ended up being 4.09 inches. Dia's ended up being 2.31 inches. Both our sample sizes were 30, and using my TI-84 calculator, I calculated degrees of freedom of 45.8. Our model was the difference in mean sock length distributed as a T model, degrees of freedom 45.8. A difference in our means, our population mean was 0 as one parameter, and the standard error was 0.86. Most of our assumptions and conditions were the same except for a nearly normal condition, but that didn't really apply here because our sample size was greater than or equal to 30 for both of our samples. We have obtaining a p-value of roughly 0.09, which is not less than 0.05. Because 0.09 is not less than 0.05, then we fail to reject the null hypothesis, as there is not enough evidence to suggest there is a difference in mean stock length between me and Dia samples.
All right,
That's it.